So today we're looking at functions. At the end of this lesson, we should be able to understand the concept of domain and range of a function, as well as one-to-one mappings. We should be able to understand and use composite functions. And finally, we should have confidence in finding the inverse of a function. Key points to recall: a function is defined by a specific range of values, and this is called the domain of a function. The range of a function is the set of values that the function maps onto. You will see that as we go, right? A function has an inverse only if it is a one-to-one mapping. Some facts to point out: an alternative function notation is this. Write y is equal to x squared as f of x equal to x squared. It's the same thing, multiple ways of writing it. The composite function fg, or it could be written as fgx, means fg of x. The inverse of a function f is denoted by f inverse. This is how I read this. What is the domain? So the domain of a function is the value of x for which the function is defined. So the domain is the x values, which defines the function. The domain of a function, rather, is a set of values that we are allowed to plug into our function. So you see, the x values, we can put it into our function. This set is the x values in a function. The range of a function is the set of values that the function maps onto. So all the y values for which a function is defined. That is ultimately what it is, okay? So the domain is the x values and the range is the y values. That's the takeaway here. We need to be able to recognize what is one-to-one mapping. This is an example of one to many. This is an example of many to one. This is an example of one to one. Let's look at the domain here, the x values, right? And this is the range. So let me say it like this. When x is 4, y is -1. When x is 8, y is -4. When x is 2, y is -9. This is an example of one-to-one mapping. A composite function is formed when one function is substituted into another function, and that's why it looks like this, right? So fg or fgx is defined as fgx. So what that is saying is this. Look at the example. If f of x is x plus 1 and g of x is x squared, then fg of x, what does fg of x mean? It means I am putting what g of x is into f, right? I'm putting g of x wherever I see x in f of x. When we get to the examples, you all will see that, okay? I'm just telling you all what a composite function is. So if you take note here, you will see that this is f of x, look at this. Here was x, right? But wherever I had x, I put what g of x was. Wasn't g of x x squared? That's why x squared is here. So this is an example of fg of x. What does fg of x mean? I am putting gx inside of f. When we get to the examples, you all will see. The inverse only exists if the function is a one-to-one mapping. How to find the inverse? So they give you f of x is equal to something, x plus 1. They want you to find the inverse. You can find the inverse of a function in 4 steps, simply by replacing the term f of x with y. That's step 1. Step 2, within the same equation that you're given, within the same function that you're given, you are switching the places of x and y. Wherever you see x, you put y. Wherever you see y, you put x. Then you solve for y. When you get your answer for y, you're simply going to replace the y with the symbol f inverse x. So let's take things from the top. Let's look at an example. Here it says, if P is equal to 10 over V, use the mapping diagram opposite to show how V maps to P for 1 is less than or equal to V is less than or equal to 10. Now, before we got to this point as well, we reviewed inequalities. Okay? So reading something like this or seeing something like this should not be confusing. So the point is, they told us what P is, and they gave us the values, didn't they? Don't we have the range? They tell us the values show how V maps to P for this. What are the values for V? It's between 1 and 10. So it means that we can use values between 1 and 10. We don't have to use all. We can use values between 1 and 10, right? Put it into this, and we'll be able to get the values. So when I determine what, let's say when V is 1, what is going to be the value of P? Those are the type of things we'll have to work out, right? We can choose any number between 1 and 10. So we have 5 here. You're all seeing 5 here as well? So we could work out when V is 5. So let's substitute the values. So here we have P is equal to 10 over, what is the value of P when V is 1? The value of P is going to be 10. Let's work out all the values and then we would map. What is going to be the value of P when V is 5? The value of P is going to be 2. Why should this look very familiar? Because when we were looking at graphs, remember, we didn't write it like this, but you should be very familiar with the table format. Does this look familiar to anybody? And usually you'll see what? X and Y. It doesn't matter if you're seeing P and V now. How is that different? Whether you're seeing P and V or X and Y. Does this table remind you of anything? So now we are using P and V in this table. P and V. I don't necessarily have to write this to record my values, but I'm trying to show you something that may look very familiar to you. When you're trying to plot graphs or draw straight lines, creating this table of value, yeah? So here we have, I'll put in the missing parts just now. Let's work on the third one. So what is going to be the value of P when V is 2? The value of P is going to be 5. So when V is 1, P was 10. Next one, when V was 5, P was 2. Third one, when V was 2, I should write 1, 2, 5. I just showing you, all right? P was 5. So this is what we have to map. Are you ready to do that? So when V is 1, this is V on this side here. Let me get my line. This is V. So when this is 0, this is 1, 2, 3, 4, 5. So this is 1. So when V is 1, P is going to be 10. So what should my line look like? It should go from 1 to 10. Do we agree with that?
Yes, miss.
All right. 1. This is the mapping. when V is 5, P is 2. This is 2. If here is 0, here is 1, then here is 2. Next one, the third one, we could have done more. We just did 3, okay? When V is 2, P is 5. So I'm going from 2, I'm going right here. And this is our mapping. Are you seeing this? All right, let's look at the next one. Again, this is recorded. It will be posted in the Google Classroom for us. I'm clearing the screen and I'm proceeding. Example 2. For the function y is equal to f of x is equal to x squared, we have -5 is less than or equal to x is less than or equal to 5. Complete a similar mapping diagram like we did just now. Values were given, just like the question before. We would select some values between -5 and +5. That we would know how to map. What values do we want to use between -5 and +5? We can use -5. We can use -2. We can use 0. We could use 5. And all we're going to do is substitute those values into the function. So we will get the values for y. Yes? So when x is -5, what is going to be our value for y? When x is -5, what is going to be our value for y? It's going to be -5. I remember I have to substitute wherever I see x, -5 squared, -5 to the power of 2. And this is giving me +25. What is going to be the value for f of x when x is -2? So wherever I see f of x, I am putting -2. It's going to be to the power of 2. -2 squared is 4. What is going to be the value of y if x is 0? And the answer is, it's going to be 0. Our final number that we have there, what's going to be the value for y if x is +5? Remember, we selected values from between -5 and +5. So it's going to be 5 squared. And of course, we are going to get 25. Let's map. When x is -5, y is 25. And do we agree that the value for y would be between 24 and 26? In the middle there? That would be my mapping. When x is -2, the value for y is 4. When x is 0, the value for y is 0. When x is +5, the value for y is 25. In this example, apart from 0, right, which maps 0 to 0, there are two values which both map to the same value. So is this an example of a one-to-one mapping? I showed you all before in the pictures what an example of one-to-one mapping will be. So that means this is not a one-to-one mapping. So if f is defined by this, what is going to be the value of f -1? How are we going to solve this? As seen before in the previous example, if they want f -1, all I have to do is substitute -1 wherever I see x. So here we have f of x is x cubed minus x. If the question wants f of -1, all I am doing is wherever I see x, in f of x, I am putting my value -1. So all I did in my second line was substitute. Pay attention to that, please. All I did was wherever I see x, I substituted -1. I saw x here, I put -1 and I raised it to the power of 3. I saw x here, I substituted that for -1. Are we clear? The second line, we are going to simplify further. What is -1 to the power of 3? What is -1 cube? What does -1 cube even mean? -1 multiplied by -1 multiplied by -1. -1 multiplied by -1 is +1. +1 multiplied by -1 is -1. A minus multiplied by a minus is going to be a plus. Are you all seeing that? So what I'm getting here, 1. What is understood to be outside this bracket I have here? 1 as well. So if you want to interpret this as -1 multiplied by -1, if this is an easier way for you to see it, that's all fine. A minus multiplied by a minus is a plus. 1 times 1 is 1. However, the answer, we are getting -1 plus 1 is going to give us 0. That's it. All I did was substituted the value for x. If f of x is defined by this, then what is going to be the value of f0? Write what f of x is. Substitute 0, because wherever x is, I am putting 0. 0 to the power of 3 is 0. Take away 0. The answer is going to be 0. So what I did here, I substituted 0 wherever I saw x, and I simplified it, and I got 0. If f is defined by this, what is going to be the value of f1? Take a moment, substitute it. So wherever we see x, we are substituting 1, take away 1. 1 to the power of 3 is 1, take away 1, which is going to give us 0. So that's going to be your answer. Let's do another one. If f is defined by this, then what is going to be the value of f5? Right, so we're going to substitute 5 to the power of 3. And then subtract 5. So the question is 5 to the power of 3 is what? 5 times 5 times 5. And the answer you get is simply subtracting 5 from it. So you're getting 125. Take away 5, and we're going to get 120. First question. F of x is equal to 2x minus 1. 1 is less than or equal to x is less than or equal to 6. So this means that you're choosing values between here. Okay? They want us to complete a mapping diagram for integer values in the domain. We want to be able to identify what is the range of this function. We'll be able to determine that when we map. And then we want to answer the question, is this a one-to-one mapping? So that's what we want to do. So how are we going to approach this question? We have to figure out what the values are. So here we're going to choose select values between 1 and 6. So what values do we want to select? As a matter of fact, we can use all the values, right? 1 to 6, and this is going to be the values of x. And for this function, as you can see, we have to find out what f of x is when x is going to be 1, when x is going to be 2, when x is going to be 3, 4, 5, and 6. So allow me to do something that some of us should be familiar with this table. We need to substitute those values to determine what f of x will be when x is 1. Don't necessarily have to do the table and then do the working, but I mean, it's a good way for you to see it. So what is going to be the value of f of x when x is 1? Substitute that into the function and get your values. So here we have f of x. What's going to be the value of f of x when f of x is? What's going to be the value of f of x when x is 1? Wherever I see x, I have to substitute 1. The value I am getting here, 2 1s are 2, take away 1 is going to give me 1. So when x is 1, f of x is 1. What is going to be f of x when x is 2? Wherever I see x, I have to put in 2. Let me draw your attention here. This is a tier, but wherever I see x, I have to put in 2. So in brackets, I'm going to put in my new value, 2, take away 1, I'm getting 2 2s are 4, take away 1, I'm getting 3. So when x is 2, f of x is 3, because you're going to have to do 2 on your own. When x is 3, what is going to be the value of f of x? Wherever I see x, I would now have to put in 3. 2 3s are 6. Take away 1, I am getting 5. The next one, when x is 4, f of x is going to be 2 4s are 8. Take away 1, it's going to be 7. So when x is 4, f of x is going to be 7. Allow me to do the values for 5, the working for 5, and the working for 6 right here. So when x is 5, when x is 5, what is going to be the value for f of x? Wherever I see x, I am going to substitute 5. 2 5s are 10. Take away 1, I am getting 9. I have one more to work out. When x is 6, what is going to be the value for f of x? I am going to substitute 6 wherever I see x. Allow me to do it right here. So when x is 6, what is going to be the value of f of x? 2 times 6 is 12. 12 take away 1 is 11. So 11 is coming here. Because of this, because I substituted my values and worked it out, now I would be able to complete my mapping. Now, when we looked at examples of mapping before, you all saw that 2 lines were drawn. One line was drawn for x, another line was drawn for y. In this example, we have x and we have f of x. So that's how we would label our lines. X, and f of x, or f. It might help. So this is 1, this is my 2, this is my 3, my 4, my 5, my 6. Right? This is my 0, this is my 1, this is my 2, this is my 3, 4, 5, 6, 7, 8, 9, 10, 11. When x is 2, f is 3. Let's use green for consistency. When x is 2, f is 3. When x is 3, f is 5. When x is 4, f is 7. When x is 5, f is 9. When x is 6, f is 11. So this is how I got my values, and this is my mapping. So part A of the question asks us to complete the mapping diagram for integers values in the domain. So this is it. Secondly, the question wants the range of this function. What's going to be the range of this function? What was given? The domain. Remember what I said about the domain? The domain is the x values that defines the function. The range is the y values that defines the function. And this is a good question to test your knowledge to see if you know the difference between domain and range. At the start of this class, we said that the domain is the x values that defines the function, and the range is the y values that defines the function. So if this question is asking us for the range, it is asking us for the y values that defines this function. So it's going to be 1. The y values are what? These values here. This represents the y values of the function. Here, this is the y values of the function. Here represents the domain that was given. We use the values of x, right? And we were able to find the y values. And now this question wants us to identify the range of this function. We already did the work. It's just to write it, just like how the domain was written, just like this. But notice the domain was between 1 and 6, right? The range, however, it's here. It's going to be between 1 and 11. So if I have to write the range, it's going to be 1 is a less than or equal to f of x is a less than or equal to 11. And that's what the question asked for. Finally, the last part of this question is asking us, is this a one-to-one mapping? Yes or no? The answer is yes. And that is the end of part A, part B, and part C. Right? Just in case you all want to look at the question again, and some of you all didn't write it down. I'm going on to question 2. I'm clearing my screen because I posted a snapshot of what I had on the board in the chat. This is question 2. Let's read question 2. It says f of x is equal to half x squared minus 1. The domain is given. Says -3 is less than or equal to x is less than or equal to 3. Because this information is given, we have the values of x to substitute into the function to get the values of f. So wherever we see x, we have to substitute one of the values, okay? This question wants the same thing. They want us to complete the mapping for the integer values. The question wants to know the range. We would only be able to determine the range after we work out the values. If they want the range, you have to be sure to start with the first number. It will be wise to start with the first number and make sure and end with the last number, so you'll know where it starts and where it ends. And then they want you to be able to determine, is it a one-to-one mapping? So when x is -3, x is going to be, here I have a half by -3 squared minus 1. I can choose to work with a half, or a half as a decimal is 0.5, so I can choose to work with this as well. So it could be 0.5 by +9, take away 1, and this is going to give us 0.5 by 9 is going to give us 4.5, and 4.5 take away 1 is going to give us 3.5. So when x is -3, f is 3.5. When f is -2, x is going to be 0.5 by -2 squared minus 1. 2 squared is going to give us +4 minus 1. So 0.5 by 4 is going to give us 2, and 2 take away 1 is going to give us 1. When f is -1, we are getting 0.5, open brackets, -1 squared minus 1. -1 squared is 1, so 1 by 0.5 is 0.5, take away 1, we are getting -0.5, -0.5. When x is 0, f is going to be 0.5 by 0 squared minus 1, and this is going to give us -1. When x is 1, f is going to be 0.5 by 1 squared, take away 1. 1 squared is 1. 1 by 0.5 is 0.5, and 0.5 take away 1 is going to be -0.5. 2, f is going to be 0.5 by 2 squared minus 1. 2 squared is 4. 4 by 0.5 is 2, and 2 take away 1 is 1. When x is 3, f is 0.5, 3 squared take away 1. 3 squared is 9, and 9 by 0.5 is 4.5. 4.5 take away 1 is going to be 3.5. Now let's fill in our values. So when x is -3, f is 3.5. When x is -2, x is 1. When f is -1, x is -0.5. When x is 0, f is -1. When x is 1, f is -0.5. When x is 2, f is 1. When x is 3, f is 3.5. They want us to map this. This is going to be my x, this is going to be f. So let's create a mapping diagram. As we can see here, the values for x is between -3 to +3. The values for f is going to be between -1 and +3.5. -1, here will be -0.5, 0, +0.5, 1, 1.5, 2, 2.5, 3, 3.5. Now let's map. So when x is -3, f is +3.5. When x is -2, f is +1. When x is -1, f is negative 0.5. When x is 0, f is -1. When x is 1, f is negative 0.5. When x is 2, f is positive 1. When x is 3, f is 3.5. So this is our mapping diagram for the integer values in the domain. The question wants, part B of the question wants the range. The range can be seen here on the diagram that we drew. It can also be seen here. And as you can see, it's between -1 is less than or equal to f of x is less than or equal to 3.5. Part C of the question wants to know if this is one-to-one mapping. As can be seen in the mapping diagram, this is not an example of one-to-one mapping, so the answer is no. That's it for this question.